for what we have concerning systems of equations. And we have for the determination of the values of x and y, we'll be looking for those that will satisfy the system, okay, whereupon we have simultaneously that 4x plus 2y is equal to -8, and where we have 3x minus 2y is equal to 29. Okay, and so just taking what we have here for the system. Now we already have additive inverse terms with what we have in y, okay, with both positive and negative y terms. Okay, so you got 2y and negative 2y, and so we can revert to adding the equations together. So I can set things up where I can go ahead and solve for x. Okay, so we have for this system, okay, so we have positive negative 2y, okay, those will cancel out. And we have 4x plus 3x, so this will make 7x. And we have negative 8 plus 29, okay, so that will make 21. And so we have for x, if 7x is equal to 21, okay, we're going to have that x is equal to 3. Okay. So I have half the solution. Now we need to determine what y is. Okay, and what I can do here is I can plug in 3 for x in either of these two equations and set things up whereupon I can solve for y. So we plug in 3 for x, solve for y. So we want to have here, I'll just go with the first equation. I'm just plugging in for x. Okay, so we have 4 times 3. Plus 2y is equal to negative 8. So we now got 12 plus 2y is equal to negative 8, and taking 12 away from both sides. Okay, so we have that 2y is equal to negative 20. And finally we have a division by 2, and we have that y is equal to negative 10. So you got x at 3, y at negative 10. You can go back and check. 4 times 3 is 12. 2 times negative 10 is negative 20. And 12 minus 20 is equal to negative 8. And we have with the second equation, 3 times 3 is 9. Negative 2 times negative 10 is a positive 20. 9 added to positive 20 comes out to 29. And so we'll have for the solution, okay, we have x is equal to 3, and y is equal to negative 10, and just writing as an ordered pair. So there's only one point of intersection between the graphs of these equations. Again, that point is going to be located at 3, negative 10. Then we have for number 18. Now I just mentioned, okay, now 17, that problem is from a different section. It's section 8.2. We won't be dealing with this. But for 18, okay, there is a blend of linear and nonlinear equations. And for 18, we're looking at solving for x and y such that we have that y is equal to x squared minus 8x plus 2. And I'll say that y is equal to negative 2x plus 18. Okay, and so for what we have in the system, okay, you have a quadratic function as well as a linear function. So for what we have here, okay, we don't have things aligned. Oops. Okay, we don't have things aligned such that we can conveniently use the method of addition. Okay, and plus we don't have the same degree in x in the equations. Okay, but what we can do in creating a pathway to solving for y is that we can use the other method. Other than the method of addition, or some might call it elimination, we have the method of substitution. Okay, so again, both equations are in terms of y. Okay, so y is equal to x squared minus 8x plus 2. We have also that y is equal to negative 2x plus 18. Okay, and with substitution, okay, now the variable we have isolated, in this case y, we can substitute for in the other equation. Okay, so like for the first equation, we got y defined in terms of x as being x squared minus 8x plus 2. And if I take this trinomial and substitute for y in the other equation, we'll have the other equation in terms of the variable x, where I can go ahead and solve for the letter x. Okay, so looking at substituting for y and solving for x, so we'll have in the rewrite, okay, so I have x squared minus 8x plus 2 is equal to negative 2x plus 18. Okay, so I have a quadratic equation, and what I can do is I can set this up as a quadratic equation in standard form. Okay, so setting the equation to 0, so I'll just move the 2x and the 18 by respectively adding and subtracting. So here I'm going to have x squared minus 6x minus 16 is equal to 0. And the trinomial I can factor, and with the terms, okay, so we have x plus 2 and x minus 8, and with the use of the zero product property, setting each of the factors to 0. So if x plus 2 is equal to 0, we have x is equal to negative 2, and when x minus 8 is equal to 0, so we'll have that x is equal to 8, right? And for what we have in the setup, okay, now we got equations of different degrees in x. And in terms of what to do, in terms of the strategy to utilize in solving for y. Okay, and just kind of a heuristic. Whenever you're looking at solving for the other variable. Use the simplest equation. Simpler or simplest. That is like the lowest degree equation. So it's kind of like with this system. Okay, if you notice, you had first equation had like squaring x. Second equation had both x and y are first degree, so that would be regarded as the simpler equation. Okay, so in this case, for this instance, we have that y is equal to negative 2x plus 18. Okay, so when x is equal to negative 2, for the corresponding value in y. So again, utilizing y is equal to negative 2x plus 18. And negative 2 times negative 2 plus 18. Negative 2 times negative 2 is 4. Plus 18 is equal to 22. So that is for one set. And whenever x is equal to positive 8, so y is equal to negative 2x plus 18 once again, this time with x at 8. So that negative 2 times 8 is negative 16. And negative 16 plus 18 is equal to 2. Okay, so we have a couple of pairs of values here. And so for what you're going to have in terms of the solution, we'll have two distinct points here. We have for x and y. Okay, so one ordered pair solution, we have x equal to negative 2 and y is equal to 22, and also in the other scenario we have that x is equal to 8 while y is equal to 2.